Here's problem 3051. The planetary model of the hydrogen atom consists of an electron in a circular orbit around a proton. The motion of the electron of charge 1.6 times 10 to the minus 19 coulombs creates an electric current. The radius of the electron orbit is 5.3 times 10 to the minus 11 meters, and the electron's velocity is 2.2 times 10 to the 6 meters per second. What is the magnetic field strength at the location of the proton? Very interesting. So we have a proton, which is the center of the atom, and then we have an electron moving around it at some radius. Negative charge for the electron, and the radius we're given is half an angstrom, 0.53 times 10 to the minus 10 meters. And we have the charge on the electron is a magnitude 1.6 times 10 to the minus 19 coulombs. And the velocity as it goes around this orbit is 2.2 times 10 to the 6 meters per second. So we can think of maybe this orbit of this charge as being like a wire of current, if you will, as this electron goes around the proton. So we are going to have a current produced as this charge moves past a point. That's what a current is. When a certain amount of charge moves past a point in a certain amount of time, that is current by definition. Current is our change in charge over our change in time. So we want to make that calculation. And so we need to know how much time it takes for the electron to go around this circumference of this circle. Well, we know the velocity should equal the distance per time, and that's going to be the circumference of the circle per time. So the time will equal the velocity, or will equal the circumference divided by the velocity. So in this case, that's going to be 2 pi times 0.53 times 10 to the minus 10 divided by 2.2 times 10 to the 6. And that's equal to 1.51 times 10 to the minus 16 seconds. Hence, the current as this electron is going around is our change in charge per time. And since we make one revolution in 1.51 times 10 to the minus 16 seconds, we're going to have an amount of charge equal to the electron, 1.6 times 10 to the minus 19 coulombs, over this 1.51 times 10 to the minus 16 seconds. And that's going to be equal to 1.06 times 10 to the minus 3 amps, or approximately 1 milliamp. Amazingly, so the electron going around the proton in the simple hydrogen atom is about 1 milliamp. Let's write that down. Approximately 1 milliamp. Cool. Let's calculate the magnetic field due to this using the Biot-Savart law. We know that if we have a current loop like this, the magnetic field at the center of the loop is going to equal mu naught I over 4 pi r times the angle theta in radians. So this is going to be equal to 4 pi times 10 to the minus 7 for mu naught. Let's actually go down here, 4 pi times 10 to the minus 7 for mu naught times the current, 1.06 times 10 to the minus 3 amps times the angle in radians, 2 pi, over 4 pi times the radius, which is 5.3 times 10 to the minus 11, or 0.53 times 10 to the minus 10. And 4 pi's cancel out. And we'll plug that in and see what we get. 12.53 Tesla. Wow. Very large. So in the simplest hydrogen atom, on a very small scale because it's very close, the magnetic field at the center of that, due to the electron moving around like a current around the atom, is 12.53 Tesla.